Okay, so yeah, I had a bit of a I I'd rather not say. Okay, now these ones are a little bit different, right? If you notice, these are the quadratic expressions where you notice you have your C first, then you have your BX, and then you have your AX squared. The only difference in this scenario is that there are quite a few of them where each of the coefficients of x squared, all of them are negative actually. They're all negative, right? So let's say, for example, let's say we're looking at, okay, wait, I might need to, okay, let me be kinder to my audience and zoom in a little bit, right? Yeah, let's do that so we can see what's going on. All right, so let's look at, for instance, the 28, right? The 28 would be positive, right? And then in this case, this here, well, in any case, this is what we do. So instead of it being ax squared plus bx plus c, it is flipped right around, and of course the a will be negative here and the b will be negative here. Now, the reason why this is relevant is because when I was going to school, factorizing one of these was a little bit more challenging, right? But if we train our eyes to look on it in a different way, then it won't be as daunting as it appears, right? Now, we're going to be doing the same AC method, right? So therefore, the only difference is instead of this being A, this will be C. And instead of this being C, this will be A. So it just, it just flipped around. But we're still going to be finding the factors of the first and the third term, right? That doesn't change, right? That does not change. So how on God's earth would we have a 36, a 14, and it would result in 55, especially when both signs are negative? You have a negative here and a negative here. That indicates that one of the numbers is negative and the other number is positive, with the larger number being negative, right? So let's say, for instance, let's say you had, I don't know, minus 70. And I'm just speculating. I'm not even saying that this is what the answer would be. Let's say you had minus 70 and 15, right? Then if you were to use this combination, this would give you a minus 55, right? For argument's sake. Now, it would be a tremendous coincidence if these two ended up being the answer. But again, I'm doing this literally all freestyle, right? I don't have a script for this, right? So I'm working it out at the exact same time that you're seeing everything. So let's have a look at 36 and 14. And we know, well, at least I do, 36 is, I think because I've been doing a lot of work with prime numbers, my brain is just wired to just seeing what it is. Well, look, all right, here's a good thing. We should, if we don't even know what 36 is, we should know that 36 is 12 times 3. So the beauty about it is that this is already prime. And then 12, I mean, 12 is just so familiar, right? All right, that was strange. Things disappeared. I didn't like that. It's kind of strange. Yeah, sorry about that. If there was a glitch that we just saw a while ago, yeah, let me apologize for that. So 12 is our famous 2, 2, 3. And if we use that and multiply it by 3, then what we'll have is 2, 2, 3, 3, right? So that is what I want us to remember about the number 36, right? So just, you know, let's bear that in mind. And this is wonderful. This has 2 and 7, right? There we go. So we're gonna use our yep. Right? Why not? Big multiplication sign. Why not? Okay. How would we use a combination of these numbers to get minus 55? Okay, I have a 9 right here. 9 times 7. Let's see. Let's see if what could we get with 9 times 7? 9 times 7, that would be 63. Okay, so let me put 63. Let me just put down the 63 somewhere. Okay, let me get rid of these numbers because we already found this out, so we don't need that over there anymore. So let me just put down the number 63. And then let's put down, well, 2 by 2 is 8. So we'll have 63 and 8. Yes, ladies and gentlemen, we found it. So, and it's the 63 will be negative. The 8 will be positive. And so it's going to be minus 63x and a positive 8x. We take 3 from 63, 3 from 8, we'll have 60 minus 5. 60 minus 5 is 55. There we go. So we successfully found our replacement for minus 55x. So let me just highlight that for a minute. So this over here is going to be replacing, well, this, right? So we're going to be replacing minus 55x with minus 63x plus 8x, right? So that's what we're going to be doing. So hopefully you stared at that long enough, right? And again, I can always reverse the process, right? So in the event that you didn't catch everything, I can always put everything back so you can see how I got everything, right? So 3 by 3 by 7, right? 7 by 3, 21, 21 by 3, 63. So that's how we got the 63. And then 2 by 2 by 2 is 8. So there we go, right? So let us begin. Let us begin. So we're going to have 36. You can put it in any order you like. You can write plus 8x or 63x here. So why not? Let's just put the 63x. I feel like this might work in our favor a little bit, you know. And then this will be 14x squared. All right, so let's start focusing on the signs now. We'll have a minus 63x, a positive 8x with a minus 14x squared. And just in case we are a bit lost, we're working on this one right here. Right, so we're looking at 51, right? So 51b, right? So we're looking at 51b, this. So we're at number 51 and we're looking at part B of 51 there. So if we're looking carefully now, this here is what replaces this right here. Right? So just want to be mindful of that. Okay. So now we're going to be factorizing. So, all right. Let me just put down the brackets. So we'll put down a bracket here and a bracket here, bracket here, and a bracket here. Now, what is, okay, I'll bite. I will bite. So let's try and find the HCF of 36 and 63. Right? We have no reason not to. We have no reason to not do it. So let's just do that. See what we get. Right? We have a, well, this would be 3 by 3 by 7. Right? 9 times 7 is 63. And this will be 2 by 2 by 3 by 3. So now it's been made very clear that it's going to be. So that's our HCF. 3 by 3. So that's going to give us, our HCF will be 9. Right? Our HCF is going to be 9. All right, so that is going to come on the outside out here. So let's put that in front of, and of course, we'll put the X there as well. Well, no. I got tricked. I got bamboozled. It has to be 9 and only 9. Why can't we put an X there? Why? Because, because remember, it's no longer ax squared plus bx plus c, but rather c plus bx plus ax squared. So because it's reversed, I cannot use 9x at this point. Okay, fine. So 36 divided by 9, well, our answer is right here. It's going to be 4, right? So this will be 4. And what is this? Let's say we were to put 63x here. We wouldn't circle or include the x. So this would be 7x. So we're going to write 7x right here, right? So now, fun story or fun fact, this is going to be the same as over here, right? Quite confident that that's what's going to happen. Quite confident that it will. Quite confident. Ah, okay. All right. I just had to check something a while ago. All right, good. Now, 7 and x right here. Now, when we divide 8x by 4, gonna have a positive 2x. And even if we did minus 14x squared over minus 7x, we're still going to get a positive 2x. All right, so we'll put the 2x here. All right, we need a plus sign in front of that right here. There we go. And as we've done before, now today I'm going to do both types, right? These are the most, as far as I'm concerned, these are the most tricky and crafty of the set, right? So what we will get in the long run is 9 plus 2x and 4 minus 7x, right? So the beauty about this is that you will never get the signs wrong, right? You won't get the signs mixed up at any point in time, right? 9 times 4, positive 36. 9 times minus 7x, minus 63x. Plus 2x times 4, plus 8x. Plus 2x times minus 7x is minus 14x squared. Therefore, our final answer is 9 plus 2x multiplied by 4 minus 7x. So our prime numbers from as early as primary school all the way up to now, when we're doing CXC, we still need the prime numbers. We still need the prime factors. Because had I not found the prime factors of 36 and 14, I would not have known what combination to use in order to get the minus 55 to be split into 2 terms, right? So I feel like we did a good job there. So, you know, let's get rid of that one. I wish well, hopefully in time when people get accustomed to me going live, we will have more of an audience, right? So, all right. Okay. Yeah, I'm trying to challenge myself with the, you know, the most difficult ones that I can think of. Okay. All right, this one looks crazy, right? You have 51 in the middle, and you have 27 on one end and 28 on the other end. All right, let us try this madness. Why not? So we will have 28. We'll have 27. I will not waste my time multiplying 28 by 27. 28 is 2 by 2 by 7. 27, that's 3 times 9, which is 3 times 3 times 3. All right. Okay. So how are we going to get this here, minus 51? How are we going to get that? All right. I'm going to go with it worked for us before. Why not use 63 and see what happens? Why not? 63 tends to work out. I don't know why. It's either 7 times 5 or 7 times 9 giving us 63. So why not? We have 63. So, okay, 63 is one of our numbers. What about the remainder? Oh, look at this. 2 by 2 by 3. That's our famous 12. So we have 12 here. And what happens when we subtract this? 3 minus 2, 1. 6 minus, there we go. There we go. But let us bear in mind, it must be a minus 63 and a positive 12 to be a minus 51. And naturally, let's put the x's right here. So we now know that we will be replacing minus 51x with minus 63x plus 12x. So let us take a careful look at what we are using. We'll be using this right here. Right? So let's bask in the excellence that is making use of the prime numbers, because let's face it, if we didn't have the prime numbers, it wouldn't be so easy for us to make intelligent guesses as to what this thing is going to be. And again, your prime numbers can be used for, you can find the HCF with it. You can find the LCM with it. You can reduce fractions because you're finding the HCF to reduce your fractions. You can use it to order fractions, right? You can, yeah. What else? I'm thinking of all the ways in which prime numbers have, you know, helped me from as small to medium to large, from simple to intermediate to more complex and expert, you know. So yeah, feeling good about it, feeling good about it. So all right, let's do away with the basking in the glory. So let's get rid of all of that now and start getting to the work. So now remember, what you're changing is the middle term. So you don't do anything to the first and third, right? Let's remember that. So your 28 shall remain the same. But then what you will have is your 63x here. You will also have your 12x. And you will also have your 27x squared. All right, there we go. So let's get to work. Minus 63 plus 12x minus 27x squared. All right. So bracket here, bracket here, bracket here, bracket here. All right, let's change the 36 to 28. And what do we have here? Prime numbers again. 2 by 2 by 7. And then we have 3 by 3 by 7. Well, it's safe to say what this is. See, that this is why I love prime numbers. Prime numbers takes away all of the guesswork. Look at that. And they don't have anything else in common, right? So that means that the HCF of 28 and 63 is clearly going to be the number 7. Now remember, typically we would put a 7x here. However, the x squared is all the way over here, so we don't need it for this bracket, right? The x will appear here instead of over here. So remember, the situation is reversed. So you might be tempted to put it here because you always put it there. But just remember, I nearly made the mistake myself. But how I was able to remember is because, let's say I put the 7x here. If I multiply 7x by 4, I will get 28x. But there is no 28x, right? So just sometimes you have the red flags, right? That's, you know, nowadays, you know, for those of us who are in the dating world, you know, the concept of the red flag, right? So anyway, so we divide 28 by 7. Well, it's right here. 2 by 2 is 4. And then what we have here, 3 by 3 is 9. So this is going to be 4. And here will be the 9x. right? So remember what happens on the left also happens on the right. Wait, I need to just fix that. Let me use a better line. So let's use that line. Yeah, let's use that line. And yeah, what you get in the left bracket, you get in the right. So this is going to be 4 minus 9x all over again, right? So both brackets must be the same. Once we can break down the middle term into two, the left and the right brackets will have the exact same value. All right, plus 12x divided by 4, that's going to be a positive 3x. Again, it would be true if you divided minus 27x squared by minus 9x. It would result in the same thing, right? 27 over 9, 3. Minus 27 over minus 9, still 3, positive 3. X squared over x, the x is canceled, leaving you with just one of them. So your answer would be 3x, right? So it's going to be a positive 3x. So yep, that's it. So let the chips fall where they may. We are going to have a 7 plus 3x here and a 4 minus 9x over there. So 7 plus the 3x here, 4 minus the 9x here. So does that help us? 7 times the 4. So let's have a look at this. 7 times the 4, 28. Perfect. 7 times the minus 9, minus 63x. That's also perfect. Now let's go to 3x times positive 4, positive 12x. And then, of course, 3x times minus 9x, minus 27x squared, right? And that's that. So if we can do these kind of expressions, we can do the normal ones as well, right? But it's good to know how to approach, you know, these are the trickiest of the lot. They are the trickiest of the lot. I mean, it just is. Just by looking at them, I see how tricky they are. So we just got done with 51B. We also did 53B. But allow me to move this out of the way so we can see that that's what we just did. So let's just hurry up and do that. All right, I can bring it back. I can bring it back. So we just did this. Just did this. So we're done with those two. All right. You know what? I wonder if we could get this one. 32 minus 52 minus 45. Could we get it? Could we get it? Let's see if we can. Let's see if we can. Let's see if we can do this. All right. We're going to use 32 and 45. Remember, it's always the first and the third. Doesn't matter if it is c plus bx plus ax squared or ax squared plus bx plus c, right? So we're going to have 32. We're going to have 45. 9 times 5, we know right? So this is going to be a 3 by 3 by 5. Now 4 times 8. Well, 2 times 2 is 4. And then, of course, 8 is also 2 times 2 times 2. All right, so this is giving us, yeah, a bit much to think about. All right. How are we going to get a minus 52 from all of this? Ah, man. Yeah. Problem is, if we have, no, no. We have to be careful about how we do this one. We have to be very careful. So let me take a guess. Wild guess. No, okay. I'm going to fail, right? So how about this? We have 8 times 5, which is 40. And then the remainder of which would be, so we'll have 40 up here. And then the rest of it would be 36. This would not work, right? So we can't just eliminate this from now. Like, there's no way this going to work. The reason being is that you have a minus and a minus. Just like if you have a plus and a minus, one of the numbers is going to be positive, one of them is going to be negative, right? So notice, plus then minus, the larger number is positive. Minus then minus, the larger number is negative. So let's get rid of that. So we can't even use that. That's not even worth attempting. So, okay, let's expand a little bit. Let's go to, let's try 15 times, well, I don't want to use 8. That's going to be a huge number. Yeah, that's going to be huge. So let me not use that. Let me dial that back. So let's get away from the 8 and dial that back to 4. Let's see what happens when I use that. So if we have 15 times 4, we'll have 60. All right, so why not? We have 60. And then what we have left is what? 3 times 2, 6 times 2, 12 times 2, 24. Yep, that's not going to work either. That's not going to work. All right? So sometimes, sometimes we get it right on our first try, sometimes we don't. Sometimes we don't. Let's see what else. 8 times 3, 24 times 3. Ah! See? I just said it out loud. So let me say that again. 8 times 3. But we don't stop there. Right. So no, okay. So just remember what I just said. 8 times 3, but instead of just 8 times 3, we multiply that by another 3. All right, so we're going to have this. We know that this is 8. All right, we're going to multiply by this. Yeah? 8 times 9, that's going to be 72. There we go. We have what we need, 72. What we have left is 2 times 2 times 5. That's going to be 20. And there we have it, folks. There we have it. So we have minus 72 and a plus 7. I mean, plus 20. See? That is it. So you have to be willing to try and fail, right? Because you're not always going to see it right away. We tried the 40 and the 36. They were too close for it to work. 60 and the 24, you'd probably end up getting 36 if you did a subtraction either way. So whether it was a positive 60 or a negative 60, you'd have gotten a positive or negative 36. And that is smaller than 52. So no, we don't want that. So with that in mind, we're going to replace the minus 52x with minus 72x and a plus 20x, right? So yeah, this again, if I'd like to give us all a reminder, that's how we got 72 and our 20. So there we go. So let's write the numbers as we remember them. What do? We'll write the 32. What else? Oh, that looks like 120. That's dangerous. Okay. So we have 32, 72x, 20x, followed by 45x squared. So minus 72x plus 20x minus, right? So there we have it. So let's go here and here. Let's go here and here. Let's use 32 and 72. So let's replace those numbers there with 32 and 72. I wonder what this is going to be. Yeah, sorry, I got distracted. We found it before. We found it before. Triple 2, which is 8, by double 3. But this will be 8 times 4. Oh, have a look at that. Our HCF is going to be here, right? So 2 times 2 times 2, our HCF between 32 and 72, that's going to be 8, right? It's going to be 8. So let's put 8 on the outside. And again, remember, because our AX squared is right here, then the number that we put in front of the left bracket will not have an X, right? So just remember that. So 32 divided by 8. Oh, that's over here. 32 divided by this 8 leaves us with 4. Let's say for argument's sake, I added the X to this. 3 by 3 is 9. This leaves us with 9X. Yep. So we are going to have 4 minus 9X here. we're also going to have 4 minus 9x there. Okay. So 20x divided by 4, well, 20 over 4, it's looking a lot like 5. And let's say we weren't sure. Well, 20 is 2 by 2 by 5. Place that over 2 by 2. And then we find our HCF, which is 2 by 2. So it's going to be 5. Since both of the numbers are positive, it's going to be plus 5. You had an x up there, 5x. So you're going to have plus 5x. So this is going to be 5, then our x right here. So lastly, we will have 8 and our 5x. 4 and our 9x. One here, here, one here. Don't forget this. Don't forget this. And just one more thing. I have 1. There we go. That's 1. Yep. So I think it's safe to say we have a good handle on these. Right? I think we have a good handle on them. So as maybe potentially, homework or whatever it might be, you can try the ones that I didn't do, right? You can try the ones that I didn't do. So always the first and the third. We have 25 and 56, 18 and 49. Well, okay. 49 is a dead giveaway. You only have 7 and 7. Some numbers are a dead giveaway. Dead, right? This one right here. 49, 7 by 7. This will be 2 by 3 by 3. So if you were to do a comparison, you'd have 2 by 3 by 3 by 7 by 7. So how difficult would it be to find out what gives us this positive 21 right here? Wow, it's right in front of us. Wow, that's, oh my God. Ladies and gentlemen, 3 times 7 is 21. And we also have another 21 times 2, which is 42. So if you have 42 minus 21, then you end up getting 21. Right? So it's a combination of 3 by 7. That gives us this minus 21 here. So this 3 by 7 gives us this. This 7 by 3 by 2 gives us this. So if we wanted to solve 52a, then that's what we need. So you'll need 42x minus 21x. Yeah, that one is pretty easy. That one is pretty easy. Pretty easy. Well, you know what? Let me do one more challenging one before we go. Well, not before we go. over, move on to, something similar. All right, let's do 50 part B, and that looks very unlikely. Very unlikely. So we have 24 and we have 21. Okay. What is 12 times 2? 12 times 2 is 24. 12 is 2 by 2 by 3. So what you're going to have is 3 2s and a 3. So you're going to have 2 by 2 by 3. And then for 27, you're going to have 3 times 7. Right? That's what we're getting. So this over here is going to be our, see, this is why we need to be careful. See, we have 24 and we have 21. I'll explain what I mean by being careful, right? I'll explain exactly what I mean. So I have the 24 times 21, and I have what I believe is the prime factors for 24 and 21. But there is something incredibly wrong. Something incredibly wrong took place. The problem is this right here is correct, but not for this number. This will only be correct if I do one more thing. I need to put 2 in front of the 12. 2 times 12 gives me 24. There we go. So now we have what we need. Right? We have what we need now. Wow. How are we gonna get 47 from this? 47. 47. Wow. And remember, you have 2 minus signs. This means that you are going to be making a subtraction and you're not going to be making, so you can't add 2 positives and you can't add 2 negatives. So let me see what combination could actually help us. What could we do? What could we use? Because we can't add 21 and 24. We can't do that. I'd love to use 63, but that's not going to work. 63 minus 8, we already used 55 already. We already did that. We exhausted that one. So I don't know if we can do that one. Oh. Yeah, this is a tougher call this time. It's a much tougher call this time. All right. We can't use 72 and 7. 72 and 7, that's not gonna work, right? So what I mean by that is we can't multiply 8 here by the 9 here. Giving us 72, 72 minus 7 doesn't work, right? So 72 and 7, yeah, we're not gonna be able to do that. So that's out of the picture. Okay, what about but this is the funny story. We can't use 24 and 21. So as is, it cannot work as is. So we have to change something. Something has to change. Something. Anything has to change. It cannot stay. I mean, okay. Nope, nope, nope. Look at what it cannot be. We have to look at everything that it can't be. So what can't it be? This is 18. Okay, let me write down that. We'll have 18 and we'll have 28. Yep, this not gonna work either. Not gonna work, not gonna work. So what do we do? What do we actually do? What do we do with this? I am starting to see it. Let's see if it will work. I can see it now. I mean, at first I couldn't, but I'm starting to see it now. So watch this. I thought of all the 7x3s and 7x9 and all of that. But you know what I never considered? I did not consider 8 times 7. Well, 8 times 7, that's going to be 56. 3x3, that's going to be 9. What happens there? Minus 6 from both of them. You'll have 50 minus 3. 50 minus 3 is indeed 47. So we found it. Finally found it. And it must be a minus, so it's going to be minus 56 plus 9. And we're going to have x here. So this will be minus 47x. And that is going to be replaced by minus 56 and a plus 9. So whatever happens, don't give up. Because see, I tried the 72 and the 7, that never worked. Tried the 18 and 28, that didn't work. I mean, I could have tried 21, but 21 would have failed. And 63 would have failed. So 21 and 24 can't work. 63 and 8, that couldn't work either. So I had to find some combination that I did not try. So just like that, we now have minus 47x. Right? So to me, the toughest part is identifying the correct pair of numbers that will replace the middle term. Once you get over that hurdle, the rest of it is a cakewalk afterwards. It really is, right? So we'll have 24. So let's write 24. Let us write the minus 56x. Beside that, we will have a positive 9x. And then after that, we will have a 21x squared. All right, so let me use my signs here. So minus 56x plus 9x minus 21x squared. All right, so bracket here, bracket here, bracket here, bracket here. All right, let me try to put a little more uniformity to it. All right, so we'll have our bracket here. Okay, 24 and 56. Now they look like multiples of 4, but you know what? Let's not leave anything to chance. Let's not leave anything to chance. So we have 24, and we have 56. Right? So we'll have this here. I will have this here. So triple, 2, and a single 7. Oh, but triple, 2, and a single 3. Ah, so guess what now? What this means is 1. Yep. So our HCF, right? So believe me when I tell you, yeah, as early as primary school to as advanced as working out quadratic expressions, we will need to use the HCF or the GCD. They're the same thing, right? Greatest common divisor or HCF. And we found that the HCF is 2 times 2 times 2. So we found out that that is 8, right? And that is what goes in front of the bracket. The HCF always goes in front of the bracket, right? So that value will be 8. So let's throw on the X here for good measure. So what's left is 7x. So we'll have a 7x right here. 24 divided by 8, that's going to be 3. So we'll have a 3 here. And of course, this minus sign will come right down here. Right, so we'll have that. Now let's go over here. There we go. So question again. If it happens on the left, it happens on the right. So it's 3 minus 7x. All right. 9x divided by 3. 3x minus 21x squared divided by minus 7x. X squared over x is x. Minus 21 over minus 7 is the same as positive 21 over positive 7, resulting in the same positive 3. But fine. Let me write the positive 3. Wait. Let me do this. Let me do this. So, am I missing anything? Let's check. 3 times 3, 9x. Nope. See, I left something off. 3 times 7x, 21x. No, that doesn't give me that either. So I need to put the x right there. Let's see what happens now. 3x times 3, 9x. 3x times 7x, there we go. So we are now going to write 8 plus 3x and 3 minus 7x. So we'll have the bracket here, bracket here, bracket here, bracket here, plus sign here, and minus sign here. And that's it. So we literally just did, so we just did this one. 50 part B, 24 minus 47x minus 21x squared. It results in 8 plus 3x multiplied by 3 minus 7x. Yeah. Wow. Let me know how long I've been doing this. You know what? I don't know. I feel like stopping here. But let's just remember that the only difference between these is just the order. Yeah? So normally you have ax squared to the furthest left. This time you have it to the furthest right. That is the only difference. But in terms of the process, we still break down the middle term into two terms. And we still use our prime numbers, rearrange them until we can get, you know, some kind of combination that will give us the middle term, right? So everything else failed. We tried to use 63 and 8, that never worked. We tried to use 21 and 24, that never worked. We tried to use, what else? 72 and 7, that never worked. We tried to use 18 and 28, that never worked. So the last thing we did not try was 56 and 9. And once we tried that, it gave us our positive or negative 47. Now, if we needed a positive 47, we would need a positive 56 and a minus 9. Right? So you just have to flip the script then. Well, yes, I am confident that all of this that I just did should be enough to tackle all of the other questions that I did not do as yet, right? So let me kindly get this out of the way so that we can look at number 54A. So maybe as a challenge, you can probably do the ones that I didn't touch, right? Like let's look at 54A, right? So, so you have 54A and you have 55A. These ones are not too, they're not too difficult. You have a 49 in there. So you know you're going to have 7 times 7. And this is 32. 32 consists of 5 2s as the prime number. So that's probably not going to be too difficult to do, right? So maybe you could do this one, and maybe this one. Maybe that. So I'm confident, but just remember, you have to nail finding the prime factors of the first and the third term. So you're finding prime factors of, let me give you the examples, 25 and 56. Prime factors of 35 and 54. Prime factors of 42 and 35. And then when you group it together, you now have to find a way to get the middle term. Now, again, in this scenario, you have a plus and a minus, so it means the larger number is positive. If you have a minus, then a minus, the larger number is negative. Right? Just like what we have here. Right? Just like what we have here. Let's So this is what we have right here. If we were to flip it around, plus 56 minus 9, we would have gotten a plus 47 instead. Right? So as long as we know, right, then we should be in good spirits to tackle the rest of this. So I am going to close off there. So again, thanks for watching, and I'll see you around.